Find d over dx of f of x if f of x equals 1 over x. Now, this is just another way of saying that we're taking the derivative. D over dx means we're taking the derivative with respect to the variable x. And this is a function of x, so it all lines up. So again, we need the limit definition of the derivative. Bing! And so we then need to actually plug in our function here, our specific function. So we still have the limit as h approaches 0. But our function, f of x, is 1 over x. It's the reciprocal function. So when we're evaluating it at x plus h, that is going to be 1 over x plus h. And we have minus f of x, which is 1 over x all over h. Now again, we need a way to get rid of that h in the denominator. We need to simplify things. And when we have a complex fraction like this, the way that we generally simplify things is by taking the top and the bottom and multiplying by the least common denominator of the smaller fractions. In this case, the LCD is x times x plus h, because those are the denominators in the smaller fractions. All right. Now, let me write my limit again. Never forget your limits. In the numerator, we're going to have to distribute the x and the x plus h to each of those fractions. When we distribute to the first fraction, the x plus h's cancel because we've got one in the denominator and one out front. And so we're left with x times 1, which is just x. It's lovely. Then we've got our subtraction. And then when we distribute into the second fraction, it's the x's that cancel. And we're left with x plus h times 1, which is x plus h. But I'm going to put this in parentheses because remember, it's the whole thing that needs being subtracting. So whatever that result is needs to be in parentheses. And then this is all going to be over hx times x plus h. Now, when we distribute that subtraction into the terms inside the parentheses, it's going to change some of the signs. So it's going to be x and then minus x and then minus h all over hx times x plus h. And then from there, we can cancel out the x's because we've got a positive x and a negative x. X minus x is 0. So we've got the limit as h approaches 0 of just h over hx times x plus h. Now here we can cancel the factor of h in the denominator and the numerator. Of course, h is h times 1, so that leaves a factor of 1 up top. And now we are at a point where we can use direct substitution, because if we plug in 0 for h, that's not going to make the denominator 0. It's going to make the denominator x, it's left over here, times the other x, which is x squared. And so we end up with 1 over x squared, and that is our derivative.